So when we multiply, we add our exponents. So what's going to happen when we divide? We are going to subtract our exponents. Okay, so go into our little graphic organizer. So x to the a over x to the b will be x to the power of a minus b. Okay? Yes, order matters, especially with subtraction. Right? Is 2 minus 3 the same as 3 minus 2? No, it is very different. Okay? So notice it's always our numerator minus our denominator when it comes to subtracting. Okay? We have to go in that order. Okay? Have to go in that order. Okay? So we're going to divide the big guys and subtract our exponents. So we're going to fill that rule in up here as well. X to the a minus b. All right, so number 1, x to the power of 5 over x to the power of 3. Tell me how to set it up. You're right. How do we set it up? 5 minus 3, which is going to give me x squared. All right, how about 2? How do we set it up? Good, 12 minus 2, so that gives me k to the power of 10. Do we like this? Is this simple? Remember that, guys. Just because I throw more stuff to it does not mean we're going to change things. Okay? Remember how you are enjoying it right now and how you think it's easy. Okay? It does not change. Okay? Here we go. M3 over M3. Don't freak out. What do I do? How do I set it up? M3 minus 3, which is m to the power of, what did I hear? And what does m to the power of 0 equal?
M to the power of
1. Good, that was on our organizer at the very bottom. And now, doesn't that make sense? Anything divided by itself is just the number 1, right? Like if that was just 3 divided by 3, it's just the number 1. So it still applies. M3 over M3, well, it is just the number 1. Good. All right, so number 4, 5, and 6. Yes, there's more there. No, I'm not changing anything. Okay? You just pair it up with like terms. So with number 4, I have an A and a B. So I'm going to keep my A's together, keep my B's together. If you have to write them out as their own fractions, you can do that. Okay? If you need to put A6 over A2 on its own, and then B4 over B3 on its own, if that helps you visually see it better, do it. Okay? Just don't be moving things. Keep them where they are. So what is my simplified A term going to be? A to the power of 4. Good. And what's my simplified B term? B to the power of 1. Do I usually write the power of 1? No. Not usually, so I'm going to leave it like that. If you wrote number 1, are you wrong? No. You're not wrong. Okay. I would like you to try number 5. You do 5. All right, so we have all done 5. Here for, for P was 7 minus 4, right? And Q was 16 minus 12. So we got P to the power of 3 and Q to the power of 4. Okay? All right, some of you have already tried number 6. Okay? If you wrote X 15, Y 0, and Z 1. If you had that on your paper, I told you you're not wrong, but you're not done. Because which one of those can you take one step further? the y0. Okay? Does that turn into just a y? Some of you had that. No. What does it turn into? The number 1. Am I going to write x15 times 1 times z? No. We're going to write x to the power of 15 z. Okay? This right here equals the number 1. So x to the power of 15 times 1 times z. We don't put the 1 there. Is anybody confused where the 15 or the 1 came from? Okay. So my x's, I have 20 over 5. So 20 minus 5 gives me 15. The 0 comes from 9 minus 9. And then the z, that's a z squared. That's technically a z1. That invisible 1. So 2 minus 1 leaves me with just 1z. This.
Where did the y go?
Where did the y go? It's raised to the power of 0. So it's just the number 1. Which we experienced right here. Okay? So yeah, we're not going to do... We're not going to write that. That's technically what it's doing.
Leave it alone.
Leave it like this. All right, ready to level up? So we're going to throw in some coefficients now. Okay? So what do I get to do with my coefficients? We get to actually divide those. We're still subtracting our exponents. We get to divide the big guys. Remember, coefficients are the big numbers, if you need to remind yourself. Okay, it's that number that's leading in front of our variable. All right, so number 7 has 6x to the 4th over 2x cubed. Just like before, if you need to separate them, separate the coefficients, separate the variables. That is the same thing. I did not change the problem. I just organized it a little bit differently. Okay. What is 6 divided by 2? 3. X4 over x3 gives me x1, so I'm just going to put x. Like that. Right from right? Yes? Okay. So how can I set up number 8? How do you want to set it up? Do you want me to break it apart like last time? Did you like that? Yeah? Okay. So I'm going to have 14 over 7. I'm going to have r squared over r, and then s squared over s. What can you put with that r and that s right there?
1, 1.
We can put a 1 if we need to. Not going to hurt anything, right? Might as well. So, separate each piece. What is 14 over 7? 2. R2 over R1? R, good. S2 over S? S. I know what you meant.
Oh.
The exponent is 1. Yeah. So, it's 2RS, the end. Alright, number 9 throws a negative at you. You gonna be okay? I think you are. If there's just one negative in my problem, then my answer is going to stay negative. Good. If I had 2 negatives, show you my hand motion here. You have 2 negatives. Those come together and make the positive. Yeah. So just one negative by itself, it just stays there. Okay, he's floating. So coming over here to number 9. Tell me what to write. Okay. Okay, so you think of it like that. Okay, and that gave us C0, which equals 1. So do I have to write it down?
No.
No.
D5 minus D2.
D2. There you go. Good. So when y'all separate it, you don't do the fractions again? Do you go ahead and switch to the subtracting exponents? That's what's going on in your heads? I want to do what's going on in your head. Okay. Think you're up for some? Yes? Not number 10? Okay, so do you want me for one more? Okay, I'll do one more, and then you're on your own for 11 and 12. Okay? Here we go. Number 10. First things first. Coefficients. Negative 15 over negative 3. Gives me what? Positive 5. Good. Negative over negative. That makes me a positive. 15 divided by 3 gives me 5. All right, then what? 6 minus 5 gives me x to the power of 1, which is just going to be x. Yep. All right, how about the y's? I heard y2. Where did y2 come from? Good. Then what? Yeah, so we have a z. Z divided by nothing. So did anything get taken away? No, so z is still there. Ooh, can I do this? This might break you. Tell me if it breaks you. I don't want to break you. What if I did that? Putting in a z to the power of 0, did I change the problem? No, technically that's just being multiplied by 1, right? I didn't change anything. That 0 shows that I don't have any. I didn't have any z's down there. So if you need something there, do that. Okay, so z1 over z0, well, 1 minus 0 leaves me with just the 1 that's there. Okay, little birds, they kick you out of the nest. Your turn for 11 and 12. We're going to play Pass the Pin, too, so y'all better be up. Oh, yes, it's happening. We're playing Pass the Pin. There's more than one way to write the answer for our next problem, okay? Most of us, from what I saw, 4 over 8 simplifies to 1/2, right? Because you can divide both pieces by 2, okay? If you divide both pieces by 2, not by 2, what am I doing, guys? 4. Divide both pieces by 4. I was thinking of the answer. We get 1/2. Okay? So 1/2 is my new fraction. N5 over N gives me N4. Okay? Plenty of you have this. This is a beautiful answer. I love it. Okay? If you converted it to a decimal, then you probably have 0.5 n to the power of 4. It's okay. It's not my favorite. Okay? I prefer the simplified fraction. Okay? Because getting 0.5 showed me you just typed into a calculator. You get what you like. Okay? But is it technically the right answer? Yes, it is. Good. This is also the correct answer. You could also do N4 over 2. Okay? That would be like multiplying 1/2 times N4 over 1 and putting it together into one fraction. Okay? I do not expect you to do this. Okay? But you do need to see it and understand it's the same thing. Alright? That's going to help us when we get to negative exponents later, next week. Okay? So it's going to come back, so don't forget it. But right now, one of those two is perfectly fine. Okay? My next one, number 12. 36 over 54. If you type it in the calculator, you get a decimal. And then you freak out on me. So don't do that. Let's try to simplify our fraction. 36 and 54 can both be divided by what number? The number 9. So what is 36 divided by 9? 36 divided by 9 is 4. What is 54
6.
divided by 9?
See, that
6.
equals 2/3, right?
Oh, so is there a bigger number? I could have also divided them both by what?
12.
Is it 12? I think it is 12. No, it's not.
No, it's not.
27. They're both divisible by 27. No,
You
they're
can't
not.
divide
Oh
those.
gosh,
It's
guys,
27.
my brain is fried.
18.
Yes,
Yes.
18. There we go. We got there together. Okay, but the fact that we didn't know it was 18, clearly I didn't know it was 18. Does that mean we're wrong? No, because I get here and I'm like, oh wait, they're both even numbers. I can do more. I can divide these both by 2 now. Okay. So if you knew it was 18, was that faster? I guess technically yes. But it doesn't mean I can't get there. Okay. So 2/3 is our simplified fraction. What's my new M?
6.
M, 6. Good. And n to the power of 3. Okay. Perfect answer. If you have like 0.66, M6, N3, again, it's fine, but not my fave. And then to do a little foreshadowing here, 2 M6 N3 over 3 is technically the same thing. Those are both over 1. So we'll do things again more like this next week. But I just wanted to show it to you. All right, ready to put it all together? Never. Well, let's put together all of the rules we've done, or not all of them. I think this is just bringing in my power. Yeah, so we're going to bring together power rule with our quotient rule. Okay, what did we say we do with exponents when we have double exponents? What happens?
Multiply.
You put them into our parentheses and you, someone said it?
Multiply.
You multiply the exponents together. Okay, we did this last Thursday, Friday. So we're going to do that first and then divide what we have left. All right. If you ever have that power property happening, you have to do it first. Okay? I see a power to a power in my top. I see parentheses. Our I should go straight to the parentheses. Do I have parentheses on the bottom? No. Am I going to touch the bottom? No. Leave it alone. I'm not messing with it yet. Just my top has parentheses. Again, it goes to everything. That is now 3 squared. X to the 5th times 2. Because you have to multiply. Okay? What is 3 squared? It is 9. And what's 5 raised to the, what's x raised to the 5 times 2? What's 5 times 2? 10. So our numerator is really 9x to the 10th. And our denominator has not changed. It is still 27x3. Sorry, that is impressive.
Wait.
What's that?
Just right.
Almost. So 9 is over 27. If it was 27 over 9, it would just be 3. But since it's 9 over 27, it's going to be what? Not 3, but
The whole thing is going to be 1/3.
1/3. Because the bigger number's on the bottom. No.
Wait, so how did you get 9?
How I get 9?
Oh.
Right here. Yeah,
I
3
forgot.
squared.
I gotta do it.
Okay. So yeah, 9 over 27, they can both be divided by 9. That does simplify to 1/3. X10 over X3 is going to give me, X10 over X3 gives me 7. There we go. We're dividing, so we're subtracting. same thing.
Wait, how do you, wait.
Power to a power, you multiply. So that's the rule you missed last week. When you have an exponent raised to an exponent itself, you're going to multiply those two together. All right? Ready for 14? No? Are we still writing 13?
Yes.
Funny, your hand's not moving.
I'm not right there, I'm saying like, yeah, like, yes, of course.
Oh, okay. Here we go, 14. Do you see parentheses? Yes, do it first. Do parentheses first. Okay? This entire parentheses is being raised to the power of 3. Everything gets the power of 3. Everything gets raised to an exponent of 3. That's the 2, that's the A, and it's the B. They all get it. Okay? They all get my 3. So that's 2 raised to the power of 3. A squared already had an exponent, so what do I do with it? Multiply. B to the 4th already had an exponent, so multiply. Does that help?
Well, you multiply like 2 times 2 times 2, right?
Correct.
For sure.
Yeah, 2 cubed is 2 times 2 times 2, which is going to give
So
me,
you do 2 times 2 times 2, and you do 4 times 4 times 4.
what's 2 times 2?
4.
4. What's 4 times 2?
8.
There you go. A to the power of 6, B to the power of 12. Did my denominator have parentheses? No. So are we going to change it at all? No. There we go.
Isn't 8 over 4 equal 2?
Is it what?
Doesn't 8 over 4 equal like 2?
Yes, 8 over 4 does equal 2. So 8 divided by 4, 2. What's the new exponent for my A? 3. Because 6 minus 3 gives me 3. B12 over B7,
5.
B5. We got this, friends. 2 more. Any questions for me at all right now? Okay. There we go. Moving on to 15. Do you see parentheses?
Yes.
Yes. Where do you see them?
The bottom.
In our denominator in the bottom. So am I going to touch the numerator right now?
No.
No. Ignore it. My denominator, though, I have 4WV being squared. Everything is going to get squared. Okay. So what is 4 squared? 4 squared is 16. W squared, well, that's nice. It just stays, right? V squared, that's nice. It stays. Because they didn't have an exponent already. Well, they kind of did. What was it?
1.
It was 1. So 1 times 2. All right, we did not mess with our numerator, which was 12w to the 9, v to the 4. Over 16 is 3/4. Yep, you can divide both of those by what? 4?
Yeah.
12 and 16
Yes.
can both be divided by 4. So that becomes 3/4. All right, what's my new W? 7. What's my new V?
2.
V to the power of 2. Good. Bonus question, what's the other way I could write it?
0.75.
Okay. Yep. Four. Okay, here. Last one, guys. We got this. Do you see parentheses? Yes. Where do you see them? Everywhere. All right, they both have them. So again, focus on numerator versus denominator. All right. So what exponent am I going to distribute through my numerator?
4.
The 4. So 2 to the power of 4. C to the power of 4. D already has a power of 4. But when we bring in another one, good, we're going to multiply it. All right, let's finish the numerator. What is 2 to the power of 4? 16. C4 is just C4. What's the exponent for D? What's up? Yes. All right, let's work on my denominator now. Let's go. All right, what exponent is going to be distributed through the entire denominator? A power of 2. Okay, so we have 2 to the power of 2. C squared to the power of 2, so it gets multiplied. And then D cubed to the power of 2, so that gets multiplied. All right, what is 2 squared? 4. What's my new exponent for C? 4. What's our new exponent for D? 6. Nice. Here we go, guys.
16 over 4 is 4, right?
Yes. 16 over 4 is 4. What's the C? C to the power of 0, which is just 1. They cancel out. It kind of looks like a giant number 1, doesn't it? They cancel out. And then D, yep, to the power of 10. Good. 4 minus 4 is 0. There's no more C's. Right? If I were to write out 1, 2, 3, 4, over 1, 2, 3, 4, don't they all cancel out? They're all gone. No more C's. Okay? Nice. Good job.